Welcome, everyone, to this very special edition of the NITheCS Colloquium, where Professor Francesco Petruccione, Director of NITheCS, will be telling us about the year 2024, which was a very special year for NITheCS. And I think we all know Professor Petruccione very well, but nevertheless, it is always a pleasure to look into his spectacular biography, so let me read it for you. Francesco Petruccione is a physicist and professor with a career spanning quantum science, computational thinking, and artificial intelligence. After earning his PhD and habilitation from the University of Freiburg, he joined the University of KwaZulu-Natal in South Africa, where he held the South African Research Chair in Quantum Information Processing and served as Pro-Vice-Chancellor for Big Data and Informatics. Now, Director of the National Institute for Theoretical and Computational Sciences and a Professor of Quantum Computing at Stellenbosch University, he co-leads the Africa-Europe cluster of research excellence in AI and data science for global challenges. Professor Petruccione has authored over 250 scientific papers and landmark texts, including the theory of open quantum systems and machine learning with quantum computers. His contributions have earned him accolades such as the Stella d'Italia honor and fellowship in leading academies, reflecting his impact on science and education worldwide. And let me also add to this, Francesco, that Professor Petruccione has been an amazing leader and director of the NITheCS initiative that is bringing so much impact and good for all scientists and beyond in South Africa. We look forward, Francesco, to your talk reflecting on 2024.
Thank you. Thank you very much, Zurab, for the kind words. And thank you very much to you here and the people online for still going to a NITheCS Colloquium at the middle of December, when people slowly start to calm down and relax. So what I want to share with you today is a little bit of a preview of the annual report, if you want, yeah, and maybe some highlighting some of the things that happened in NITheCS this past year, and maybe indicating some of the things that might happen next year. Yeah. Since we are an institute for theory and computation, maybe let's start with the humanities. Yeah. Let's start with a little bit of history, just for those of you that maybe are not so familiar with NITheCS. Yeah. Back in 2008, why don't you see my slides changing? I can see them here. Sorry. No, not not there. They're changing here, but they're not changing there. Sorry for this. Okay, let me start again. Okay. Yeah, it's there. It won't work. It never worked like that. It needs to work like this. Yeah, now it's there. It's still there. And it doesn't change there. Yeah. Okay. Okay, sorry for that. Let's start again. So I wanted to start with a little bit of history. Yeah? So back in 2008, we we had the National Institute for Theoretical Physics, yeah, which followed a recommendation of a panel that reviewed physics to do something more in the country for theoretical physics. And NITEP was quite successful over the years, but unfortunately run as a center of excellence, so that after 3 times 5 years, the sunset clause kicked in. But because of its successes, a plan was put in place to transition it to a bigger institute. Now, if you can't survive small, there's always a chance that you can survive big. Yeah, and so several committees were set up to analyze the scientific case for a bigger institute. Then eventually the roadmap was approved, then the implementation plan kicked in, and eventually 3 4 years ago we started the transition process. So NITECS is based on 4 pillars: research, training, engagement, and opening up to the African continent. Yeah? And what makes NITECS really different is that it's not just a monodisciplinary institute. Yeah? We cover 8 disciplines: yeah? Theoretical physics, astrophysics, mathematics, statistics, data science, quantitative biology, including bioinformatics, quantitative finance, earth systems, and climate change modeling, and eventually data science. Yeah? So it's quite tempting to call it an undisciplinary institute, yeah? Because you need to find a way to get all the disciplines to work together. And that is where, from history, we switch to philosophy. Yeah? Because to make it work, we need to agree on some basic philosophical underpinning. Yeah? You know, if you have these 8 disciplines, it's quite tempting to say, okay, we just call ourselves a multidisciplinary institute. Yeah? But that is not good enough, because we don't just want the 8 disciplines to work side by side, yeah, as is somehow indicated in this graph. Yeah? And we don't want to be an interdisciplinary institute either, yeah, because interdisciplinary means there is a little bit of exchange between the disciplines, something goes back and forth, but not necessarily something really impactful comes out of it. So the approach that we prefer is the pandisciplinary approach. Yeah, so we want to put at the core the challenges that we want to address, and all disciplines need to contribute to the solution of the problem. Yeah? So this is a little bit the change in perspective that we want to implement. We want to integrate really all the disciplines for the solution of problems. So if you play a little bit with ChatGPT, you can even come up with dictionary definition of pandisciplinary science, and you see that the accent is really to focus on critical challenges that you want to solve in the interaction of all the various disciplines involved. So pandisciplinarity, yeah, has 3 probably characteristic features. Yeah? One is that all disciplines contribute without any hierarchy. Yeah? And I know that some theoretical physicists have a different point of view, those that operate more like Sheldon in Big Bang Theory. Yeah, that thing. Yeah? But the idea is to be really inclusive of all disciplines, to focus on problems. Yeah? We want to focus on problems, not on topics, and really collaboration 360-degree. Yeah? So this is really what we want to achieve. It's not a completely new concept, this pandisciplinarity, yeah, because you know it goes. 2 typical examples are, for instance, the Apollo program. Yeah, to bring man to the moon was not just a monodisciplinary effort. Yeah. Another beautiful example is the Human Genome Project. And in their official logo, you see there already 1, 2, 3, 4, 5, 6 disciplines officially mentioned in the logo. Yeah? And without all disciplines working together, we would have never accomplished what the Human Genome Project achieved. Yeah? So it's something that has been demonstrated, and there are, of course, many other examples. Yeah? Pan-discipline doesn't mean that that is not a rigorous thing. Yeah, and the reason is, of course, that there is no royal shortcut to geometry. Yeah, the people knew already thousands of years ago. And in the same spirit, there is no royal shortcut, for instance, quantum technologies, yeah, because to realize the vision of the quantum internet, we need physics, mathematics, computer science, material science, engineering, and so on and so forth. That is really complex, integrated efforts of many disciplines. And climate science is another typical example. Yeah? To put it another way, yeah, more in an African context, yeah, it's nice to look at NITheCS as a village, the village that we need to achieve some of the goals that we want to achieve. Yeah, the major one being to raise the next generation of scientists. And now comes the other aspect of the philosophy. Yeah? In order to realize all this, what we really need is to embrace open science. Yeah? Open science is really should be the foundation of everything that we do, because otherwise all collaborating, sharing, and so on and so forth doesn't work. And, and in times of ChatGPT, yeah, open science assumes even another dimension that we sometimes forget. Yeah? It also means open access to computational resources. Yeah? And I will mention it again at the end, because the gap between the computational resources accessible to people working in industry and people in academia is increasing exponentially. Yeah? It also means open codes, yeah, for high performance computing to run code on big clusters of GPU. And very importantly, also open weights. Yeah? All these language models, none of us would have the ability to train a large language model. We just don't have our own infrastructure for that. Yeah? So we need to have access to open weights of this large language model to be able to sort of competitive. So this is a kind of an additional aspect of open science that is becoming more and more important. This for the NITheCS associates, yeah, what is very important, yeah, to DSI and NRF is that NITheCS is not a mini NRF. Yeah, it's not a funding agency. We are really a research institute. So we will put our resources in our very own research project, yeah, that we want to set up, or that we are setting up. Now, next step. This is how we, okay, I'm doing. I think I'm going very fast. The consortium. Yeah. Again, let's start with some history. Yeah. The transition started in April 2020, yeah, because when I was appointed as interim director of NITheCS, there was no NITheCS. There was still NITAB. Yeah. And then, during the following months, the roadmap was approved. We worked on the implementation plan. We started working on the so I think I made a mistake. From February it goes to June. I think that connection line should be on the other side. Sorry. Yeah, the call for a consortium was issued eventually in August last year. Stellenbosch won the consortium. We started officially operating as NITheCS in April this year. Yeah, in May, eventually the interim status of the director disappeared. Yeah. And a few weeks ago, we signed the consortium agreement. So now NITheCS has a legal status. Yeah, and that is very important, because it means that essentially we are ticking all the boxes now. We are a consortium, and this is also very interesting, of all universities in the country. So it's inclusivity moves across also to the universities in NITheCS and AIMS. AIMS is also part of NITheCS. Stellenbosch is the hub. We are organized in 5 nodes, yeah, and the nodes have branches. Yeah, so a little bit like a bank. Yeah, yeah. And we have already a network of more than 300 associates scattered across these universities. So I mentioned we are organized in these 5 nodes. We have a node in the Western Cape, a node between the Eastern Cape and the Free State, a node in KwaZulu-Natal, a node across the North provinces, if you so want, and a node in Gauteng, which is probably the one that has the most universities for obvious reasons. And if you want to see the geographical spread, that's how the nodes are organized. There you see there's a really high concentration of university in Gauteng, a very high university concentration in the Western Cape, and the others are a little bit more equally distributed, with some nodes being really widely spread with very few universities in the respective provinces. But ideally, one day we should have 9 nodes, one per province, that would take better care of the geographical distribution. So how do you organize 27 institutions? Yeah? When we had NITEP 3 nodes, it was very easy to keep everybody connected with each other. With 5 nodes, it's sort of also possible, but with 27 branches plus hub, it's a mess. Yeah? So that's why we opted for an organizational structure that's a little bit more fractal, if you want. Yeah, we have the hub connected to the institutions that host the nodes. Yeah, in these cases, UCT, WITS, Northwest University, NMU, and UKZN, and UCT, WITS, and so on and so forth are leading the node and connected to the branches in their region. Yeah? And we tried, every node should have 4 or 5 university. Gauteng, unfortunately, has a little bit more, but that's how it is. Yeah. So that's how we are structured. Yeah, and this is also how the funding flows through the institution. Yeah? Because we have an agreement between Stellenbosch and the nodes, and we have 5 agreements between the nodes and its branches. And all together, we have an MOU that summarizes what we want to achieve. So since 2021, so in 2020, NITEP had around 70 associates. Yeah? Then the transition to NITECS started in 2021, and you see that every year we've added more or less 50, 60 associates to the count. Yeah? And at the end of 2024, just these last couple of days, yeah, we have reached 341. Yeah? What is also interesting is to see how these associates are distributed across the universities. Now you see Stellenbosch as the hub. We have 60 associates. We have the institution with the largest amount of NITECS associates, surprisingly followed by Northwest University, who took UKZN and WITS that were already part of the old NITECS. Yeah? And this is a very nice sign, because it means that the character of the old NITEP is really vanishing very rapidly. Yeah? And then, of course, the distribution of many universities, you can probably give a look. The distribution per node is also similar. Yeah? You see, there is a long concentration of associates, almost 2/3 between Western Cape and Gauteng. So the number in Gauteng somehow didn't. Gauteng is too small for such a large number. Yeah? But it's 113. Yeah? So that's how the distribution is, and you see there are still provinces in which NITECS really has to grow. Yeah? But it's also true on the other side that those are provinces where there is a very small number of universities compared to the Western Cape and Gauteng. Not only the geographical spread is changing, the distribution across discipline is also spreading. Yeah? Originally, we started 100% theoretical physics. Now we have, I think, 99 theoretical physicists, but maths is catching up very rapidly. Yeah? They're already at 72, followed by data science. Quantitative finance is very strong. We all thought it was a small discipline, but they really embraced the NITECS concept. For instance, astrophysics, that I thought would be a very large community, we have only 26. Yeah? So, it's different communities react in different ways, but it's very nice to see that theoretical physics is more or less a third, yeah? Just above a third of a quarter, yeah, of the associates. So we can't be seen anymore as a theoretical physics institute. Theoretical physics and mathematics have the majority in the NITECS parliament, so we could easily form a GNU. Yeah. So that is very nice. And of course, some disciplines are small. Climate change modeling is not a huge discipline in terms of people involved. And we can see clearly in which direction we still have to grow. Yeah. But slowly we are getting there. Compared to the same statistics of last year, there's a very big improvement. So very important to us in Stellenbosch at the NITheCS headquarters. And I'm very pleased to mention, and that's why my physics colleagues hate me, that the renovations are in full progress, yeah? Because we can hear the renovation music all day since several weeks, and we will hear it probably for several weeks ahead. Yeah? But, and I showed these slides before, this wing on your left-hand side, the ground floor of the physics department will become the NITheCS offices, and this is the view from the top. Yeah. And the moment we move in, we will start looking for bigger premises because we will realize very quickly that NITheCS deserves much bigger spaces going forward because we keep growing. Yeah, so that's really very nice. How is NITheCS governed? Yeah. We have, of course, several structures. Yeah. DSI and NRF are, of course, at the top. We have a steering committee. We have a scientific advisory committee. And we will introduce a stakeholder committee in which we invite, for instance, all the DVC's research of all the university to keep them updated and to get their, their feedback on a regular basis. We have an executive management committee, yeah, which representatives of which gets the input from the nodes, from the associates, from the focus areas. Yeah, I will speak about those just now. So according to the roadmap, we should have a head of research, a head of training, a head of engagement. We don't have it yet because so far we didn't have the financial means to afford it. At the moment, we just have the heads of the nodes represented in the management committee together with the representative of the associates, which at the moment is Professor Zura Bianelidze, and the operations manager, that is Rena Kotzer, sitting there at the back. Yeah. But going forward, I think we will work towards including these roles as well because the complexity operation, I think, justifies it. So as I said at the beginning, we are not supposed to operate in isolation. Yeah, we have through AIMS, which is one of our consortium partner, we have access to the AIMS network across Africa. We have also an MOU with ICTP, yeah, which gives us access to the ICTP headquarters in Trieste, but also to other ICTP-related institutes in South America, in Rwanda, and in China. And it's important to remember that the MOU with ICTP comes with funding, so there is an allocated budget to allow South African researchers to visit ICTP and in the other direction. Yeah? So don't be shy if you see interesting activities at ICTP to register, yeah? Because we can support them. Since a year or so, NITheCS is also part of an ARUA, the Guild Cluster of Research Excellence around AI. This also opens up very interesting connections to other African universities, but also to a handful of universities in Europe. Yeah? And this is very important to start tapping into EU funding through this network connections. So here also you see in this map that there are parts of the world where we are not yet engaging with, but slowly but surely we will get there as well. And hopefully next year we will, if I do a similar talk, there will be a few more hats on other continents. So research is one of our pillars, and this year we supported these research programs, but we have been asked by NRF and DSI to start working on a 5-year research plan, and I will say something about it just now. You know, if you look from the top to what NITheCS does, first thing you do, you look what is the research output of NITheCS. Yeah? And these are just, you see, since 2020, there was probably no NITheCS publication or publication with NITheCS affiliation. Today, we already have an output close to 200 publications per year, yeah? Which sounds impressive, but it should be much higher, because with 300 associates, if each of them has just one paper, we should have at least 300. Yeah? So the aim for next year is to get close to 300. Yeah? So this is very good. And people don't have to fear that NITheCS steals the publication money, because we don't access it at all. So that that has always been like that, and it will not change. If you investigate a little bit in Scopus, the topics of the publication, you see that already now it reflects more or less the distribution of the associates. Yeah? So this is also really very nice. Yeah? Again, physics, okay, in the Scopus category, physics and astronomy and astrophysics are in one category, but you see physics and mathematics are the two biggest chunk, followed by the others, so that more or less it reflects it. And this is already very healthy. As I mentioned, we started this year, several months ago, a process to identify the focus areas, the research focus area for the next 5 years. Yeah? And some of you have been involved in that process. And let me maybe skip this. And we came up with 10 research programs. Yeah, I just mentioned them briefly. Yeah, we have one in random order. Yeah, one on computational modeling of functional materials for driving sustainable innovation. We have one on computational theoretical gravity, astrophysics, and cosmology. One on mathematical structures and foundations, and for foundations and innovations, headed by Zurab, who is sitting here. Yeah, we have one theoretical physics themed on decoding the universe, quantum gravity and quantum fields. One on Afrocentric solution for disease control and health, data-driven African healthcare solutions. One mainly on statistics topic, elevating data analytics and machine learning in South Africa. One on climate and earth system modeling. This is the one that I think already mentioned. To develop a South African community earth system modeling platform, yeah, which is something that we don't have. Driving innovation in finance and for sustainable growth. Yeah, this is our quantitative finance one. Complexity in biological system, with the acronym E5, unraveling complexity in coupled earth, environmental, economic, ecological, and evolutionary system, headed by Kang Hui, who is sitting here. Thank you for coming. And last but not least, one on quantum technology. What is very nice is that I didn't mention it. Each focus area has one coordinator. Yeah. And the distribution is not 50-50, but we are getting there. Yeah. It is much better than the distribution, in the gender distribution of the associates, which is not so good as this one. Yeah. But we are working on that. But now come very interesting slides. In this 10 research program, we have, as per today, where we had the last meeting to finalize the focus areas, 238 research associates already involved. That means 2/3 of the about 300 and odd research associates are actively involved in our focus area. It would be ideal to have 300, but as time moves on, I'm sure we will reach that. But starting with 238 is a very, very good sign. Yeah? And here again, you see some focus area, like the one around mathematics, really managed to get 60 associates involved, yeah, which is really a job well done. Well done. So thank you very much, Zurab, for that. Others have a little more work to do. Yeah, we won't want to shame anyone. Yeah, but the fact that overall we have 2/3 of the associates already involved is, I think, is a very, very good collective effort. So thank you very much to the associates for that. Yeah. This is also interesting. If we look at which one of the 27 institutions are involved, yeah, in the focus areas, it's 23 out of 27. So there are still 4 institutions where we need to do some work and get them to join us in our research programs. Yeah? I think we have already all institutions involved in our training programs, yeah, that I can show you later. But we need to do a little bit more effort to reach out to colleagues at institutions that are not yet actively involved in the focus areas. But we will get there. This is also interesting, the number of institutions per focus area. Yeah? It's the same data, just I was just playing around with representations. Yeah? For instance, again, the mathematics focus area managed to get associates out of 19 institutions in the country. So they don't have all, but they're very close. Yeah? This is, of course, the ideal case, that we have associates of all universities working on the same focus areas. Yeah? Others have, of course, much less. Astrophysics is also doing very well. They have 15. Yeah? But you can see who needs to go out there and look for collaborators at more at more institutions. Yeah? Because we don't want our focus areas to be focused just in a couple of usual suspects. We want them really to broaden and go out and reach out to everybody. This is the involvement of historical disadvantaged institutions in the focus areas. You see again, maths is leading. They have 5 involved. Some of the focus areas don't have anyone involved. Yeah? So those coordinators have homeworks to do. Yeah? They have to go out there and, and try to find associates that work in their respective research areas. Okay. What is the time? Okay. Now, the point that I want to keep stressing is that it's very important that our focus area address real challenges, because we really want to do impactful science. And we should always have in mind things like the sustainable development goals as, as problems that we want to address. And I'm really happy that our climate change community really has identified a problem that affects us and they want to solve it, because we don't have a local South African, Southern African climate change model, and that's what they want to do. So that will be really very nice. Yeah? And in times of AI, I'm really happy that our data scientists and statisticians have put together a very nice research program to improve the use and the efforts in AI and related topics. That's really very nice. Let's keep this. So the problem really that we want to address, and this is one in which I have been involved, is really, and this is about sustainable food security, trying to use the modern tools that we have accessible at the moment to solve really big challenges. Because sustainable food system implies not only growing maize somewhere, implies taking consideration of climate change, of the nutritional value of what you produce. If you can't grow something here and you can only produce it there, we need to transport it at that cost and so on and so forth. So it's really a very complex business. Yeah? Okay, this was the research. One other pillar of NITheCS are training programs. Yeah? And before I list some of the things that we do, I just wanted to share, the way in which we try to operate. Yeah? Because we are a national institute, everything we do needs to scale up. Yeah? We can't do things that happen only in Stellenbosch. Everything we do needs to scale up to 27 institutions. Yeah? And the summer school with the CHPTC that we started long ago, is a very nice example of that. You see, in 2020 was the last time, or 2021 was the last time we did it in person, just before COVID started. Yeah? In 2022, we went online and we reached, instead of, let's say, 50, 60 students that came together in a venue, let's say 200. Yeah? In 2023, we realized we can scale it up much better. Yeah? And we started organizing venues at all universities in the country. Yeah? More than 30 venues, because some university have more than one campus. Yeah? And we broadcast the lectures, providing tutors in the venues at their own university. Yeah? And the number jumped to 800. Yeah? And this is the model of all that that we should implement for everything that we do. Yeah. For instance, even the colloquium. If people at let's say at WITS watch the colloquium, they should come together in a venue at WITS and have some snacks and drink afterwards, like we do here. Yeah? And the same at all branches in NITheCS. Yeah, so that's what we what we want to achieve. Because as I mentioned before, collaborating without interpersonal interaction doesn't really work. So we really need to increase that as well. So this model works very well, and we try to adopt it to everything that we do. All we do is not only broadcast, yeah, we also record everything. Yeah? And we have already, since 2020, a library of 717 videos, yeah, of all lectures that we have ever organized, with more than 100,000 views. But what is really more impressive is the 11,000 hours that people have watched, yeah, which means that people really watch. Yeah, because that's a lot of hours. Yeah, and our YouTube channel, we still can't make money out of it, but we have already more than 2,000 subscribers, yeah, which I think actually very nice. And the numbers keep increasing. You see, from the number of views gets bigger and bigger. Yeah, so which is a very nice development. One of the things that we also started doing was we set up the South African Theory and Computational School, yeah, with the aim of offering and broadcasting lectures at honors and say and master level. Yeah. But again, it's important to remember that NITheCS is not a university, so we don't award degrees. So we still need to work on finding a formula so that students that attend these lectures can get credits at their own university. Yeah? And this is an aim similar to the National Graduate Academy in Mathematics and Statistical Sciences. And we started some discussion to see how we can join the effort to have maybe a more uniform and coordinated offering of lectures in theoretical, computational, and mathematical sciences. We have lots of events. Yeah? We have weekly, monthly, yearly events. Weekly, we have our colloquium, which is probably our flagship event, but we have also weekly webinars on all topics of NITheCS. We have a weekly, almost weekly micro school that we started this year, in which we ask students or postgraduate students, we started with the NITheCS bursary holders to offer in 15-minute snippets just to share a skill that they've learned. Could be how to do something in Python, how to plot something, how to solve something, how to use a database. Yeah? And we are building a, a library of YouTube videos on basic skills that are useful for our researchers and students. Yeah? Monthly, we have the very popular mini school. Yeah, every Wednesday afternoon. It's mini school time. Every month is dedicated to a topic. Yeah. We have carpentry workshops where we train people in basic computational and Python and data science and bioinformatics skills workshop. With the cluster of research excellence, we started a monthly series of master classes. We have mentorship program. And then yearly, we have the various summer school, our yearly internship program, and yearly associates workshop, and hopefully we'll be able to let the associates workshop grow into an annual NITheCS conference of sorts. Yeah, so that you know, there's lots of things you can do with funding, so we need to organize that. Yeah, but that's where we want to where we want to go. This year we had, so this is just a count, yeah, 157 such events. In fact, it's much more because, for instance, the mini school is 10, one per month, but it's 4 lectures, 4 double lectures, so it's many more. Yeah? So almost every second day there, there is some NITheCS activity somewhere in the country. Yeah? So we've been very, very, very busy. And we want to do more. Some of other trainings event that we've done, we've collaborated on short courses. We did the teacher training day. We hosted one heat of Fame Lab. Okay, SATAX courses, we offered 13 this year. We collaborated with other institutes in organizing hackathons, our workshops. Okay, that was more or less the same data as before. Yeah, so these are specifically training dedicated events, and probably there are some more that we forgot yesterday. Okay, these are the sorry, come one by one. Just to give you an example, the courses that we offered in our SATAX class. Yeah. Okay. Sorry. Okay. I won't go back, otherwise I have to scroll it again. Yeah, but it was very nice to have around 100 students take part in these courses. And historically, the numbers are also increasing from semester to semester. Yeah? We try to take part in various engagement events. Yeah, for instance, we are represented at the AI Expo, at the Science Week, at the Science Forum, at the CHPC conference, at Indaba X, and the next one will be in Stellenbosch next year. People want to assist, you're most than welcome, yeah, and so on and so forth. Yeah, so we do lots of engagements also in collaboration with ICTP. Maybe for those of you that are not so familiar with NITheCS, what NITheCS can offer, yeah, we have internship programs, masters, PhD, and postdoc fellowships, and I think we should integrate that also with honor scholarship. Yeah, NITHEP intentionally didn't have honor scholarships because originally it had some, but then what it turned out that the students that were doing honors with NITHEP bursaries ended up not doing a master's in theoretical physics, and that didn't really justify the means. But now that we have 8 disciplines, even if they do an honors project in theoretical physics and ending up a master's in mathematics, it doesn't really matter. They still remain in the family. Yeah, so that if the funding permit, I think we should reactivate the honor scholarship program at some stage. Yeah? For academics, we have categories of associate, junior associate, we have strategic associates, institutional associate, and and the associates are the engine of NITheCS, because they are the guys who do the research, and through the research access the research resources that NITheCS can provide. Okay, let's come slowly to an end. Yeah? I mentioned at the beginning the gap in computing access between industry and academia. Yeah? This is a recent paper that was even mentioned in a commentary in Nature just a few weeks ago. Yeah? And you see the number of the ratio of academics that have access to clusters with more than 64 GPUs is very, 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 very small. Yeah? So that we really need to do something to fill this gap. Yeah? If you look at this in terms of naked number of GPUs, yeah, the CHPC, which is at the moment the second largest high performance computing center in Africa, as a cluster with 30 GPUs. Yeah? Oak Ridge National Laboratory in the US has 30,000. Yeah? Tesla has 100,000 and is working on 1,000,000. Yeah? So let's assume we want to reach Oak Ridge. And then we need to raise by a factor of 1,000. Yeah? That's the gap that we have. Yeah? So we really need, I know that the CHPC is planning an extension starting from next year, so that number will increase. Yeah? But it needs to increase by a considerable factor if we want to stay competitive. Yeah? You know, companies like Microsoft and Google have infrastructure budgets in the dozens of billions of dollars. Yeah? And those goes mainly in GPUs. Yeah? and memory. Yeah? So we really need to be fully aware of that. Yeah? What NITheCS has been working on, not so much in the last few months, uh, but um, but it's still high on our agenda, yeah, is to promote a kind of a distributed supercomputer. Yeah? And the idea is to piggyback on the infrastructure of the SKA, yeah, that has dishes all over the place, yeah, and setting up there one kind of supercomputers, yeah, but also satellite ground station and data collection centers for climate change and meteorology and so on and so forth. Yeah? And and the idea is by pulling all strings, yeah, is that it looks like it could even be possible to make such an effort self-sustainable. Yeah? And and that's, I think, that probably the model in the spirit of open science, open data, open access, the model that maybe we should aim to implement. Yeah? And there was a little bit of positive interest and support, and we will keep working that and see what we can do. Yeah. So, but coming now to the real end. Yeah. In order for all this to be successful, yeah, the problems are not technical. The problems are philosophical, are philosophical and social. Yeah. So we really need all of us to embrace open science. We need to have really open communication channels that will allow us to collaborate on all fronts. Yeah, because that's the only way that we have to really solve the challenges that we face. And it is really clear that only by doing impactful science we will be able to make our NITEX effort sustainable. Yeah? And also, in collaboration is probably the best tool that we have to achieve the transformation goals that we have. Yeah? And it's very important that we involve the junior associates in the research programs so that they can grow into senior associates very quickly. Yeah? Sustainability, by focusing on big challenges, we have also the chance of applying together for serious funding. Yeah, and if we solve the challenge, it will lead to even more funding. Yeah, so we really need to work together and address important problems. Yeah, and that's it for today. But if you have questions, I will be more than happy to answer.
Thank you very much, Francesco, for this very wide ranging and clear presentation, very interesting presentation. Any questions, any comments?
Yes, I just want to echo that. Thanks. And it's very impressive. You've basically been 1 year in operation. So I think you've gone far in setting up things. What is your thinking around, you mentioned sustainability, but also in terms of impact and in terms of monitoring and evaluation? How do you foresee that going forward? Because many of the outputs, the things that you presented are outputs,
Uh,
but the next step.
Yeah, no, impact, we all have a gut feeling for what impact means, yeah? But it's very difficult to nail down in numbers. Yeah? It can mean many things to many people. Yeah? But the easiest way, I think, to look at it is really to solving challenges. Yeah? For instance, the example of the climate change team. Yeah? They really want to set up a climate change model for Southern Africa that we don't have. And if they manage, and I'm sure they will, yeah, that would be impact. Yeah. And in all the other focus areas, we also need to focus on something that needs a solution and we need to provide. Yeah. And if other stakeholders in government or suggest us to get involved in something, yeah, we should listen carefully, and if we can help them solve the problem, solve it. Yeah. That's what impact means. Yeah. And that's why I really like my idea of pan-disciplinary science, yeah? Because that really puts the challenge at the center. And depending on the challenge, we need to get the input of whatever discipline is available, yeah? Of whatever resource is available, and action. Yeah, yeah.
So it's not just the discipline as well, which it's important. It's very similar, your idea of pan-disciplinary, it's to transdisciplinary, you know, it's
No,
they're
it's different
interlinked.
because in transdisciplinary, there is not the focus on solving the problem. Yeah, that's the difference.
Ah, okay, I have different understandings, but it's the disciplines and the actors, as you said, the different stakeholders, and you have that stakeholder forum, which is going to be essential.
Thank you. Any other questions, comments? Yeah, hello, Francesco. So I have a little bit radical view, as I always have a radical view. So you show this ratio between the GPU in CHPC and the GPU in Oak Ridge Lab and also Tesla. They are absolutely disproportional and so on. And of course, we all know the GPU is very expensive. And underlying those big number difference is the power of our country's economic power and so on. So my radical view is maybe it's not realistic to compete with American on AI or data science. Maybe Africans should find a niche area that we can be excellent ourselves and to have our unique contribution to science instead of competing massively on those computing powers on AI, etc., which we're hardly to catch up in a short time. So that's my radical view. So you may agree or disagree.
No, I see the point, but I think it's not just a matter of competing, it's also a matter of national security. Because what if a future government in the US, in Europe, or in China decided not to give us access to their cloud? What do we do then? Then we can't do anything. So maybe we don't need 1,000,000 GPUs in the CHPC, yeah? But give us 1,000. Yeah, yeah. And then we can apply our mind and see what we can do, something more clever in AI, yeah? You know, if it's another talk, yeah? But if you look at the electricity consumption of data centers, it's huge, yeah? There are few countries, probably the US and China consume more electricity than all the data centers in the world. Yeah? So if we apply our minds, and we can up, and we were discussing with Ian and Shivani this afternoon, yeah, come up with large language model that don't eat so much electricity, yeah, that don't need so much water, yeah, and do something reasonable. Yeah? So it's not just competing. It's like, you know, it's like cryptography. Yeah, you need to have a secure way of communicating. Yeah, and it's not competing. It's just kind of strategic relevance. Yeah? That you don't want to be completely cut off all of a sudden. Yeah, sometimes I keep repeating myself. Yeah, but the whole of Africa missed completely the semiconductor revolution. Yeah. And countries like South Korea, Japan elevated themselves after the Second World War completely from poverty similar to ours to where they are today. Yeah? And if we keep missing the industrial revolution, yeah, we will never catch up. Yeah? So, good to find a new niche. That's perfect. Yeah, but we need to find it. Yeah? And we can't miss opportunities.
Thank you for that. Let me now switch to the online questions, and then we'll come back to the in-person questions. I think there is one question that has come up online, if I'm not mistaken. So here's the question, Francesco, from Wittemele Molezane. Of the 17 SDGs and the family disciplines of NITheCS, which of the 17 goals will be of priority focus?
They will all be of priority focus. And, we tick probably several of those already. Yeah, and in the SDGs, I think all the goals are on the same level. There's not that there are goals that are more or less relevant than others. Yeah? You know, we have 8 disciplines. Let's tick 8 goals at least. Yeah. So we will. You know, I didn't study how many SDGs we tick off. Yeah, but I think it's definitely quite a few of them.
Thank you. Let's come back to in-person questions and comments if there are any further ones. Maybe I will ask you a question meanwhile. So
Please.
recently we heard the news that this TIMSS, do you know about the TIMSS thing? This is the international assessment program for scoring countries based on their school learner mathematics results. And I think it was grade 5 or 4 where South Africa scored last in the list. Do you think that a challenge like this, which because mathematics is certainly the school mathematics is certainly a very important foundation for later entering into theoretical and computational sciences, do you think NITheCS would be able to, in some way, impact that challenge, the challenge of mathematics, access to mathematics at this school level? What do you think about that?
No. Super NITEC will solve that as well. We, I mean, we already started offering online revision classes for matric and things like that. Yeah? And recently we started a discussion through DSI and with DSI to reach out to the network of science centers in the country, yeah? And join forces with them to address this issue. Yeah? And the idea was to offer additional classes of sorts using the infrastructure of the science centers to elevate education in mathematics and so on.
So the picture that you had where the center was the challenges, would this count as one?
Yeah, no, that's one of the challenges.
Okay.
Yeah.
Any other questions? We have time for possibly one. If there are any other questions or comments. Nothing from online as well? Well, in that case, before saying thank you, I want to remind everybody that we could have continue our conversations outside with nice drinks and meals. And unfortunately, this is only for the in-person participants. And thank you very much, Francesco, for your talk.
Thank you very much for coming.